You're trying to get smart on the important stuff. Yeah. Cut through all the noise, figure out what's really going on, but, without spending ages doing it.
That's the goal.
Well, that's exactly what we do here. Today, we're taking a deep dive into something pretty important. How Apple is beefing up its AI, they call it Apple Intelligence, while, and this is the key part, trying to keep your personal data private.
That really is the core tension, isn't it? We all want smarter tech, the cool features, but there's that worry about privacy just getting, well, thrown out the window.
Exactly.
And we've got a really interesting source today. It's a research paper straight from Apple's machine learning research folk.
Oh, right from the source.
Yep. It's called Understanding Aggregate Trends for Apple Intelligence Using Differential Privacy. Gives us a real peek behind the curtain at how they're tackling this.
Okay, so our mission today is pretty clear then.
Yeah.
Let's unpack how Apple plans to make its AI better, thinking, smarter suggestions, those cool Genmoji image generation, writing help, without wading into our private lives.
And we'll be looking closely at two main techniques they talk about. Differential privacy, which isn't totally new for them, and this other thing called synthetic data.
Synthetic data. Okay. So think of this as your shortcut to understanding a really critical piece of the tech puzzle. All right, let's get into it.
Well, Apple's been banging this drum for a long time. Privacy by design. They seem to genuinely treat it as like a fundamental right, not just marketing speak.
Yeah, they're pretty consistent on that message.
And it's not just talk. The research points out they've been using differential privacy for years in their opt-in device analytics. That's how they improve things like keyboard suggestions or battery life stats.
Right. I think people forget that. They've been gathering data to make things better, but crucially in a way that stops them seeing what any one person is actually doing. It's about seeing the big picture trends.
Seeing the forest, not the individual trees, exactly. And that same idea, that philosophy, is carrying over to Apple Intelligence. A really central point in this paper is that they are actively not training their main AI models on users' private data or, your interactions.
That's a big statement.
It is. They even mentioned filtering public internet data they might use, trying to scrub out things like social security numbers or other PII. That shows a pretty serious upfront commitment.
Okay, so that brings us to a really specific example they give. Improving Genmoji. Now, for people who opt into sharing analytics, Apple's using differential privacy to figure out which Genmoji prompts are, well, popular. Why should we care?
Well, the practical side is interesting. If they see lots of people are trying to create, say, a cat riding a skateboard, they can tweak their models to get better at generating exactly that kind of image. Makes the feature work better for common requests.
But, and this is where the privacy angle kicks in again, right? They're not just reading every prompt everyone types. How does this differential privacy thing let them spot the trends without spying on our creative Genmoji ideas?
Right. So the paper describes this thing they call random polling. It's like your device might get asked anonymously, hey, did you see a prompt fragment like astronaut recently?
Okay.
But instead of just saying yes or no, your device sends back a slightly fuzzy answer. Sometimes it's true. Sometimes it just sends back a random alternative. Maybe it says it saw banana or nothing.
Huh. Okay. So throwing some noise into the system.
Precisely. And they carefully control how much noise, how much randomness. They calibrate it so a specific prompt fragment needs to show up like hundreds of times across many devices before it even starts to register as potentially common.
So it needs a lot of signal to cut through the noise.
Exactly. So Apple can see the broad trend. Lots of fuzzy signals pointing towards Wizard and Castle, but they absolutely cannot link any one signal back to your device specifically.
Got it. So they see the overall demand, the pattern, but not who asked for what. And the paper really stresses that this signal isn't tied to your IP address or your Apple ID. That feels pretty important.
It's crucial. It breaks that link between a specific request and a specific person or device. It's all about understanding a collective vibe without compromising anyone's individual privacy.
And this isn't just for Genmoji then?
No, they state pretty clearly that this same differential privacy method, with all the same protections, is planned for other Apple Intelligence features too. Things like Image Playground, Image Wand, the Memories feature in Photos, writing tools, visual intelligence. It's a core technique for them.
Okay, so differential privacy seems like a solid tool for those short, frequent kinds of things like a quick prompt. But the research also mentions it's maybe not the best fit for everything, especially longer stuff like emails, right? For summarization or writing help. Why is that?
That's a really good point, and it leads us into the second big technique they discuss, synthetic data. Basically, for longer texts, the kind of noise you'd have to add with differential privacy to protect privacy would probably drown out the useful signal about topics or styles. It just wouldn't work as well.
Right. Too much noise, not enough information alike.
Exactly. So they came up with this other idea, creating artificial data. Data that looks and feels like real user data in terms of structure and topic, but contains zero actual user content.
Synthetic data. Okay, so like fake data that mimics the real stuff. How does that work in practice? They give that example. Would you like to play tennis tomorrow at 11:30 a.m.? But how do they know what synthetic emails to make to help improve summarization for, say, my inbox?
This is where it's acts quite clever, I think. First, they use their own large language models to just generate a whole load of these synthetic messages covering different topics. This is all internal, no user data involved yet.
Okay, generating fake emails.
Then, they create what they call embeddings for these synthetic messages. Think of an embedding as a sort of mathematical representation, a digital fingerprint that captures the essence, the language, topic, length, style, without being the text itself.
Like a summary of the characteristics.
Kind of, yeah, a numerical summary. So now they have a library of these synthetic fingerprints.
Got it. What next?
Okay, these synthetic embeddings, these fingerprints, get sent out to a small group of devices from users who've opted into device analytics. Now, on your device, and this is super important, it takes a small sample of your recent emails. The actual content never leaves your device.
Never leaves. Okay, crucial point.
Absolutely. Your device then calculates the embeddings, the fingerprints, for those real emails on your phone. Then it compares your real email fingerprints to the library of synthetic fingerprints it received.
And it finds the closest match.
It finds the synthetic embedding that's most similar in topic and style to one of your recent real emails.
So my phone is basically signaling, hey, that fake email about scheduling lunch, that's kind of similar in vibe to an email I saw recently.
Pretty much, yeah. But then, using differential privacy again, it sends a signal back to Apple. But the signal isn't "I matched with the lunch email." It's a noisy signal, indicating which synthetic embedding was the closest match, but obfuscated. So Apple can't be sure exactly which one your device picked, and they certainly don't know which real email it matched against.
Wow, okay. Layers of privacy there.
Definitely. So Apple collects all these noisy signals from everyone participating. They aggregate them.
And by doing that, they learn which types of synthetic emails, which fingerprints are popping up most often as being similar to real emails across many users.
You got it. They don't see your emails. They don't even know for sure which synthetic email your device flagged. But they see that overall synthetic emails about, say, meeting arrangements or project updates are frequently being matched.
That lets them understand the common themes and styles without reading anything personal.
Exactly. And they can then use those popular synthetic fingerprints to generate more synthetic data for training or testing their summarization models. Or they could generate variations, like changing tennis to soccer in that example, to broaden the training. Figure 1 in the paper actually shows this flow visually.
That really is quite an intricate system. So let's just quickly recap the privacy protections there because it sounds important.
For sure. 1, it's only opt-in users. 2, your actual email content never leaves your device. Apple never sees it.
Right.
3, your device only sends back a noisy, anonymized signal about the closest synthetic match. 4, Apple only sees the aggregated statistics from many users, not individual matches. And 5, they use the same kind of noise and aggregation systems as they do for Genmoji.
It really sounds like they put a lot of thought into locking that down.
It appears so. And the paper mentions they're already using this synthetic data approach in beta software to improve email features and plan to use it for enhancing email summaries soon for opt-in users. So it's, actively being rolled out.
Interesting. It's definitely a novel way to approach it. Wonder if others will adopt similar methods.
Could be. As AI gets deeper into personal data, these kinds of privacy-preserving techniques might become more common or even necessary.
So wrapping up the core idea here, Apple seems to have this two-part strategy, right? They're leaning on their experience with differential privacy for the quick hits, the prompts and such.
Mm-hmm.
And they're pioneering this synthetic data generation for understanding trends in longer, maybe more sensitive stuff like email content.
That sums it up well. The stated goal throughout the research is clear. Improve Apple Intelligence, make it smarter and more helpful, but do it while rigorously protecting the privacy of users who choose to help by opting into analytics.
And these methods let them see the big picture, the popular trends, without needing to peek at anyone's individual data, whether it's a Genmoji prompt or an email.
That's the core promise. And they do mention their ongoing work in this area, pointing to other research on things like homomorphic encryption, their general privacy principles, and how their foundation models work both on device and on servers. It signals that this privacy focus is pretty deep-rooted.
It definitely seems central to their whole AI push.
It does. It really highlights that fundamental challenge. How do you innovate rapidly in AI while also building and maintaining user trust around data?
Yeah, it's a big question. Okay, so bringing our deep dive to a close for today, we've looked at how Apple is trying to walk that tightrope enhancing AI with Apple Intelligence while keeping user privacy front and center.
Using differential privacy for those shorter interactions like Genmoji prompts?
Right, getting trend data without specifics, and then this newer synthetic data method for understanding patterns in longer text like emails, again, without ever accessing the actual content.
The key takeaway is really about getting those aggregate insights, understanding the what's popular without needing the who or the specific what from any single user.
Yeah, exactly. For you listening, the bottom line is Apple is developing these complex systems specifically to avoid seeing your individual creations or messages while still learning how to improve its features overall.
A focus on the collective, not the individual.
Which leaves us with a final thought to maybe mull over.
Hmm.
Looking at these methods, Apple's deploying differential privacy, synthetic data, how might other tech companies tackle this balance between pushing AI forward and respecting user privacy?
Yeah, what are the pros and cons of these specific techniques as AI gets, even more embedded in everything we do?
Definitely something worth thinking about.
For sure.
Well, thanks for joining us on this deep dive. We hope it's given you a clearer, faster understanding of a pretty complex but important topic. Until next time.